Well, Krebs cycles or citric acid cycle, or which is also known as the TCA cycle, is a series of a chemical reaction which occurs in the matrix of mitochondria. That pyruvate come from the glucose and amino acid in the cytoplasm, enter into the mitochondria, and under the presence of pyruvate dehydrogenase complex, convert into acetyl CoA. Now here the acetyl CoA is not only coming from pyruvate, but it can also be obtained from the fatty acid and from the alcohol, and then that acetyl CoA will go into the TCA cycle. Now let's take a look in this TCA cycle. Well, it looks so dangerous, right? There are so many substrates and products, and there are so many enzymes working over here, and there are lots of energy businesses going over here. So it's look a bit difficult, but it's as simple to remember. It's very simple. Like, the main thing we have to do is, firstly we have to memorize all that substrate, all that molecule which are going to be used over here as a substrate or as a product of one another. Well, the acetyl CoA condenses with oxaloacetate, and the product will be citrate in the presence of citrate synthase. And then the citrate will convert into isocitrate in the presence of aconitase. And then again, isocitrate is going to be converted into alpha ketoglutarate, and the enzyme which works here is isocitrate dehydrogenase. We have to remember this isocitrate, and don't take any tension about that enzyme, because only you have to put that dehydrogenase behind this isocitrate, and that will be your enzyme at that point, isocitrate dehydrogenase. As the same way, the alpha ketoglutarate use alpha ketoglutarate dehydrogenase and convert into succinyl CoA, and then the succinyl CoA use succinyl CoA synthetase and convert into succinate, and this succinate is going to be changed into fumarate by the help of succinate dehydrogenase, and then the fumarate convert into malate by the help of fumarase, and the malate will convert into oxaloacetate by the malate dehydrogenase. Well, there are lots of enzyme, right? I have highlighted all the enzyme with green color over here. But the main enzyme we have to remember in this cycle is all that 4 dehydrogenase, that is isocitrate dehydrogenase, alpha ketoglutarate dehydrogenase, succinate dehydrogenase, and malate dehydrogenase, because all the energy molecule which we're gonna obtain from this cycle is going to be obtained at that 4 points, and also at the succinyl CoA synthetase, where the substrate level of phosphorylation occurring. Now the question is, in this reaction we can see that NAD is reducing in NADH, and one FAD is also reducing at FADH2. Then where that NAD going to reduce, and when and where that FAD going to reduce? Then first of all, we have to keep in our mind that all that dehydrogenase enzyme, 4 dehydrogenase enzyme, is going to reduce either NAD or FAD into the NADH or FADH2. Well, then it's simple that 3 NAD is going to reduce as NADH in that 3 different dehydrogenase enzymes, right? But when and where that one FAD is going to be reduced at FADH2, then the succinate, when it's going to change into fumarate by the help of succinate dehydrogenase, is going to reduce FAD. And it's easy to remember because the product of this succinate and the presence of this enzyme is fumarate, which the first letter is F, and also like FAD also have F. So it's easy to remember that the enzyme which is going to be reduce the FAD as FADH2 is succinate dehydrogenase. Now the another important is substrate level phosphorylation. Then when the succinyl CoA is going to convert into succinate, at that point the substrate level of phosphorylation is occurring. Well, it's also quite easy to remember because succinyl S, succinyl CoA synthetase also S, and succinate also start from S, and substrate level of phosphorylation also S. So I think it will make easy to remember that between the succinyl CoA and succinate, the substrate level of phosphorylation is occurring. Well, let's talk about some okay, before talking about some important points, I have made one mnemonics for that, all the substrate and product, to make you like remember very easy. And if you guys remember that all 8 substrate very easily, then that enzyme will be also be very easy for you to remember. And as I have explained, that you have to focus on that dehydrogenase enzyme and the succinyl CoA synthetase, so it will be easy. The mnemonics is Can I keep selling sex for money, officer? The can, the C for citrate, and the I, isocitrate, keep, ketoglutarate, selling, succinyl CoA, sex, succinate, for, fumarate, money, malate, and officer, oxaloacetate. Now let's talk about some key points of this cycle. The citrate, which is the product of condensation of that acetyl CoA and oxaloacetate in the presence of citrate synthase. It's when go outside from the mitochondria by the citrate shuttle, it inhibits the phosphofructokinase 1, which is a well regulated enzyme in glycolysis. So it's gonna inhibit that enzyme. And when citrate shuttles occur, they also help to formation of fatty acids in cytosol. Now another one enzyme is isocitrate dehydrogenase. It is well regulated enzyme of this TCA cycle. It's gonna inhibited by ATP and NADH and going to be stimulated by calcium and ADP. Now there is another enzyme called alpha ketoglutarate dehydrogenase, which is also a complex enzyme like a pyruvate dehydrogenase complex. If you guys have a good knowledge about that how the pyruvate convert into the acetyl CoA, and that there is one complex enzyme, the pyruvate dehydrogenase complex, is gonna help over the year. That is also a complex enzyme, and this is also complex enzyme, and that enzyme have 5 coenzyme. That all 5 coenzyme are also present over here. It also requires thymine, lipoic acid, CoA, FAD, and NAD. Now let's talk about succinyl CoA synthetase, where actually our substrate level of phosphorylation occurring. It's also known as the succinate thiokinase, and it works between succinyl CoA and succinate, where the substrate level phosphorylation occurs. The another enzyme is succinate dehydrogenase. Well, this succinate dehydrogenase is also used as a complex 2 in the electron transport chain. When we discuss about electron transport chain, at that point also we're gonna have a discuss about this succinate dehydrogenase, and it's convert one FAD into FADH2. And now let's talk about the malate. The malate, by a malate shuttle, it will go into the cytosol from the mitochondria and help there in gluconeogenesis. Now we already know that TC cycle is mainly occurs in order to release energy, right? So let's talk about that. How much energy can we gain if all that NADH and FADH which are we have gained from that cycle, if that all will go into the electron transport chain? As we know that one NADH is equal to 2.5 ATP and one FADH2 is equal to 1.5 ATP. And in this cycle, we are having 3 NADH, which we multiply by 2.5, then we gain 7.5 ATP. And for one FADH2, we can get 1.5 ATP. And also there are one substrate level phosphorylation occurring, which means 1 ATP also gained from there. So the total amount of ATP will be the 10 ATP from one TCA cycle. Like if one glucose will go in glycolysis, then that give us 2 pyruvate molecules, and that 2 pyruvate molecules give us 2 acetyl CoA, and that 2 acetyl CoA go into 2 different TCA cycle. So if you look, that one glucose will give us 20 ATP, but here we're talking about the one acetyl CoA will go in TCA cycle, then from one TCA cycle we can get 10 ATP. Now let's look at what are other things which gonna inhibit this TCA cycle. Then the most important is a malonate, which gonna inhibit the succinate dehydrogenase. Then there is arsenate, which gonna inhibit the alpha ketoglutarate dehydrogenase, and there is fluoroacetate, which gonna inhibit the aconitase. Well, that's all about TCA cycle.